Good morning, ladies and gentlemen. So as you probably remember from Algebra 1, finding the slope of a straight line is fairly straightforward. We just use y equals mx plus b. So in this equation, we have y equals 1x. So that means that the slope is 1 everywhere. So this guy in the picture climbing up the hill, he's never going to go downhill, it's never going to get flat, it's just always constant. The slope is always 1. So it's never going to be downhill, never uphill. It's just always constant. So when we try to find the slope or the steepness of this line, we just say m equals 1. And it's everywhere. Everywhere it's equal to 1. At x equals 2, it's equal to 1. At x equals negative 2, it's still equal to 1. You're always just traveling in this straight line. So you might be wondering, what do we do if we have like this cubic function? Sometimes it's going up, sometimes it's flat, sometimes it's going down, and then it goes up again. So how do we find the slope? It's different everywhere. So our solution is the derivative, and that's what we're going to learn today. The derivative helps us find the slope or the steepness at different points. So when x equals 1, we can find the derivative there, and that derivative is going to be different than the derivative here at x equals 0. So we're going to get lots of different answers, and the question will ask you something like, find the derivative at x equals 1. And so we're going to find the slope or the steepness at x equals 1. So you can kind of see in this picture, this black line right here is the derivative. That is the slope. So at this point, that star, that is the derivative. So you can see it's not accurate for the whole line, because the whole line isn't this slope, because the line's changing. But at that point, this is its slope. So just some notational things before we get into it. You'll remember the equation of slope, y minus y1 divided by x minus x1. And so that was our equation for slope when we just had a linear line. So we're using the same sort of notation. So the change in y minus y1, divided by the change in x, or x minus x1. So then we have kind of a shorthand notation for this. Instead of writing it out every single time, change in y divided by change in x, we just kind of do a shorthand, dy divided by dx. So that's how you write the derivative. So instead of saying derivative, sometimes I'll say dy dx. So whenever I say change in y divided by change in x, or dy dx, or derivative, those three things all are talking about the same thing, which is just talking about the slope or steepness of the line. So I think we should just go ahead and dive in, and I'll show you how to do these problems. So this question right here says, find the slope, or the derivative, at x equals 0. So x equals 0 is right here. So if we just look at it, it's going to have a slope maybe something like that. I mean, we're not sure, but hopefully our answer is going to be a negative number. So we'll see how that all turns out. So to start off with this problem, I'm going to say dy divided by dx equals, so the derivative. And now this is where the formula comes in that is pretty straightforward. So all you do is you take the number that's in the exponent and you move it out front. So we'll put a 3 there. And we keep the x the same. And then we subtract 1 to the exponent. So 3 minus 1 is 2. So that's the first part. Now we go on to the next term. So for the next term, we take the exponent and bring it out front. So in that case, it's 2 times 2. So we're going to get 4, and then you subtract 1, and so you get x to the 1. Okay, doing pretty good so far. Now we're going to move on to the next term. So now we have minus, and this is an imaginary 1 right there. We're going to bring it out front, and then we have x, and then we minus 1. So 1 minus 1 is just 0. And then we move on to our next term, and this is where it gets kind of interesting. This is the same thing as x to the 0, 2x to the 0. So you take the 0 and you bring it out front. So we have minus 0. And then you subtract 1. So that's x to the negative 1. Well, 0 times anything is just 0, so we can just cancel out this whole term. So there is some simplifying we can do. I mean, you can see like x to the 0. So what we have is dy dx equals 3x squared plus 4x minus 1. So that is our general equation for the derivative. So that means we could plug in any x value. In this case, they want x equals 0. So we're going to plug in x equals 0 to each of these, and then you can see 3 times 0 is 0, plus 4 times 0 is 0, and you get minus 1. So our slope is -1. So that's our answer. The derivative is -1. Now notice, it's not -1 everywhere. It's not -1 here. It's not -1 here. Just at the point x equals 0, the slope is -1. Okay, so that's not too bad. So now let's do another example. So in the last derivative example, we were talking lots about exponents, but now you look at this function, y equals the square root of x minus 3x. And you're saying to yourself, Miss Kingsley, what are we going to do with the square root of x? Well, another way to write this is y equals x to the 1/2 minus 3x. That's another way to say square root. X to the 1/2 and square root x are exactly the same thing. So now we go back to our old rules. So let's find the derivative. dy dx equals, so we take this and we bring it out front. So we have 1/2 x, and then we minus 1 to it. And 1/2 minus 1 is -1/2. And then we minus, this is a 1, and we bring it out front. So we still just have 3. And then we have x, 1 minus 1 is 0. So now we can simplify this. dy dx equals 1/2 x to the -1/2 minus 3. And x to the 0 is just 1, so I'm going to simplify it as 3. Now in this example, they never said we want to find the slope at x equals 1. They didn't give us a point. So this means this is just our answer. So that if someone were to come along, they could just plug in any x value into this equation and it would give them the answer. So let's try another one together. This one's a little bit longer. So this one looks pretty straightforward, all exponents. So we'll go straight to dy dx, so change in y divided by the change in x equals, and we bring this out front, -8x minus 1, so to the -9, plus 7, bring it out front, 7x, and then we minus 1 to it, so that's 6, minus, take the 3, bring it out front, 3x minus 1 to the 2. And there again, it didn't say they want the slope at a certain point. They just wanted the general equation for the slope or the derivative. So there again, this is our final answer. Okay, now we have this one. So this one's a fraction. So you might be saying to yourself, what in the world do we do when there's a fraction? Well, this is another one of those tricks where it can be written y equals x to the -2. So you might remember from algebra that whenever you add a negative to the exponent, it flips it over that fraction bar. So y equals x to the -2 is the exact same thing as y equals 1 over x squared. So now we'll go straight into the derivative. dy dx equals, take the -2, bring it out front, so -2x, and then you get minus 1, so that's -3. And they didn't ask for equation again, so we just have dy dx equals -2x to the -3. Okay, and here we go. Now this is back to one of those ones where they want you to find it at a specific point. So dy dx equals, take the 3, bring it out front, 3x, then you minus 1 to the 2. But then we're not quite done like we were in the old problems because they want to know when x equals 2. So 3, and then you just plug it in. Where there was an x, you just plug it in. So that equals 3 times 4, which equals 12. So for this function, when x equals 2, it has a slope of 12. So the graph probably looks something like this. So when x equals 2, it has a slope of 12, which is pretty steep right there. So that's something with the graph. Okay, so that's all of the problems I have for you. So now I want you to get with a partner and do these problems on your whiteboard. For each of these, I just want you to find the derivative. For the first two, just find the general equation for the derivative. And then once you get down to number 3, notice that it says at x equals 4. So you'll actually have to plug in x so you can get a specific slope. So get with your partner, and I'll give you 10 minutes, and then I will randomly call 3 pairs of partners to come up and do it on the board. So on your mark, get set, go.